Teacher beliefs, their influence on technology integration and impact on professional development by Timothy Scott Jr. How do teacher beliefs influence technology integration, and how can teacher experiences with technology influence the creation of professional development were the two questions that I researched in my project. I received a grant for the purchase of graphing calculators, and I wanted to ensure that the graphing calculators were integrated in the science curriculum. My problem was that teacher beliefs and barriers to technology integration occur when teachers are introduced with new technology. And my need for this project was that teachers are expected to integrate technology in the classroom. When I was researching this, I researched technology integration, and I learned that when technology is incorporated into all phases of teaching and learning, you have achieved technology integration. There are two types of barriers to technology integration. The first is extrinsic barriers, also known as first-order barriers. And they are barriers that are quickly removed with funding, such as a lack of access to technology or software, planning time, and technical and administrative support. The second barrier are called intrinsic barriers. And those are embedded in the teacher's own beliefs about teaching, beliefs about technology, unwillingness to change, and instructional models. Teacher beliefs are also a part of intrinsic barriers, but they can also be separate. And teacher beliefs refer to a teacher's opinion about education, learning, and students, and those beliefs strictly relating to the educational setting, specifically how students learn. Pedagogy and classroom management are the most tightly held. Teacher beliefs about how students learn and effective teaching are related because their beliefs impact how the teacher will integrate technology into their own classroom. I also looked into professional development, and I learned that long-term in-depth training equals greater results. Focus on the subject matter in a hands-on student-centered manner also achieves greater results, and that you also need to increase teacher knowledge and skills. There's three characteristics of effective professional development. First one would be deep science content and process knowledge with numerous opportunities for practice. You need to be able to demonstrate competence with what you have learned, and you also need to share what you have learned. My methods for this project, I did a qualitative research study on the experiences and reflections of 3 8th grade science teachers at a large middle school. My 3 participants were, first one was Julie, a pseudonym. She's been teaching for 30 years. She's a novice when it comes to graphing calculators, and she has limited competence with technology. Tim was a researcher and participant, has been teaching for 7 years. He's a novice with the graphing calculators. However, he's quite competent with technology. Wanda has been teaching for 5 years. She's highly experienced when it comes to graphing calculators because she used them in her professional geology career, and she's also quite competent with technology. 2 lessons were taught using the graphing calculators. The first one is called It's Just a Lunar Phase, and here students identify patterns in the different phases of the moon by graphing and estimating the percent of illumination. The students then spot trends, and they calculate percent error to their estimations. The second lesson they taught was called Tilting Earth, and they explored the relationship between Earth's 23.5 degree tilt on its axis and the effect on the average monthly temperature in 2 major cities, Dallas, Texas, and Buenos Aires, Argentina. Data was collected through a pre-lesson survey of 6 questions and a post-lesson survey of 4 questions, and a collaborative conference. During this conference, the participants discussed their experiences using graphing calculators, their thoughts and concerns on the lessons, and ideas for the creation of a professional development for the next year. The researcher took notes during the meeting to document what was said during the 30-minute conversation. During the data analysis, I, the researcher looked at the extrinsic or intrinsic barriers and teacher beliefs. And since beliefs are the teacher's opinion about education, learning, and students, and the analysis of the responses, if the belief dealt with the calculators, then the response was categorized as an intrinsic barrier. Otherwise, it was left as a teacher belief. I'm going to highlight 5 results that I felt were very pertinent. The first one was, what kind of teacher would you describe yourself as? And Julie described herself as that she struggles with technology, which is an intrinsic barrier. She does have the teacher beliefs that she's willing to try new things after much analysis. Tim described himself as student-centered, while Wanda described herself as a facilitator. Thoughts on technology integration in the science classroom. Julie had an extrinsic barrier that stated computer labs are hard to get into, that there's a lack of planning time for new lessons or for finding new lessons. But she believes that technology is not always effective in the classroom. Tim felt that technology integration increased student engagement in the material, and that the technology must be used properly. And Wanda believes that technology is a tool, not a learning outcome. It assists in driving change. Students find their own answers, which leads to increased collaboration. What are your concerns about using the graphing calculators? There were 2 extrinsic barriers that were identified. Julie had one that dealt with teacher training and the use of the calculators, and Tim felt that there could be some technology glitches. Tim also felt that there'd be some student intimidation using the calculators, that the students may not understand the instructional concept. And Wanda believed that the lack of student training and familiarity with the calculators could be an issue. After teaching the lessons, did you have any belief changes? And Julie said yes, the student engagement was a large part of her change in belief. Tim also had a slight change in beliefs, that the student engagement with technology increased, helped me. And Wanda said no, she still believes that technology is critical to student development. And did technology enhance student learning? Julie says that the data was easy to enter and graph and read. Tim said that students interacted with concepts in a new way. And Wanda said that this was an additional modality for personal learning experience. Calculators were viewed as a variable technology instrument, and it also segregation of core curriculums was addressed, math separate from science. In conclusion, I researched 2 questions: how teacher beliefs influence technology integration in the classroom, and how teacher experiences with technology could influence the creation of professional development. The first one was, in conclusion, I felt that Julie had the largest change. She said that the student engagement with the calculators changed her beliefs, that the data was easy to enter, graph, and read, and anecdotally, she has since used the calculators many times in her classroom based on her experience, one-time experience with these. While integrating the technology, doing this project, the researcher experienced some extrinsic barriers. The first one was the installation of the requisite software on the classroom computer. That installation of the software took the entire first semester of the school year. The second one was that the probes that we currently had on hand could not be used with the new calculators because the probes have an Ethernet plug and the new graphing calculators have a micro USB slot. And it required the purchase of an additional piece of hardware called the Vernier EasyLink. Those are $60 each, and we had to get funding for that, and those did not arrive on campus until very recently. In conclusion, for the professional development, during the collaborative conference, we agreed that the first step should include a lesson walkthrough for each grade level that the teachers can take back with them and teach in their classroom. Each grade level team should teach a lesson using the calculators at some point during the year, and that the teachers should present their lesson to the rest of the science department. Some limitations in this project were that only 3 teachers were involved in the study. Only 2 lessons were taught using the calculators, limiting the amount of data collected. There was only 1 pre- and post-lesson survey collected, and the lack of quantitative data. Going forward, I would like to have had some quantitative data to help support my qualitative data. And I'd like to use either a Likert scale or some other measurement tool. In the end, there were some positive outcomes out of this project. The 6th grade science team, based on the feedback of the participants, they started integrating the use of their calculators into their lessons recently, especially once we received the easy links. They were able to connect some new motion probes to the calculators, and they were using those in the classrooms just recently. Here are the references as cited throughout the PowerPoint presentation. Thank you for your time.